Hi friends, welcome to my channel. Let's have a look at problem 413, Arithmetic Slices. This video is actually a follow-up for today's challenge problem. In other words, the number 0 field subarrays. In this video, we're going to share two solution formats. So one is in the form of dynamic programming, and the other is in the form of two-pointer sliding window. So the two treatments are essentially the same, but might emphasizing different thought processes. So notice that I added quotation mark in the different. So essentially they are the same, but depending on how we interpret the coding or the solution. So first, let's look at the problem statement. So an integer array is called arithmetic if it contains of at least 3 elements, and if the difference between any two consecutive elements is the same. Here is an example, right? Like this one. The difference of consecutive elements are 2. So here 0 difference. Here are -4, I guess. So given an integer array called nums, we are required to return the number of arithmetic subarrays of nums. So here a subarray is a contiguous subsequence of the array. So here are two examples. So actually for example 2, the return should be 0 because there are actually one element which is less than 3. And in the second example, this is a arithmetic array as a whole. So this is also very special, right? So you can interpret example 1 as an arithmetic piece or chunk in a larger array. So I guess that's actually that kind of array catches the generic example for this example. Here the constraints or additional assumptions for this problem is that the length of the list of nums is bounded in between the closed interval given by 1 and 5,000, and both sides inclusive. So here 5,000 actually quantifies the problem size or give us a upper bound of the problem size. And secondly, the elements in the list is bounded above in absolute value by 1,000. In other words, it in between -1,000 and +1,000. So with that said, actually we can directly do the coding because this problem is very straightforward. First, so here I'm going to get length of nums. So if you like, you can do something like this. If n is less than 3, so we're going to return 0 because to be arithmetic, it needs to consider at least 3 elements. But if you do not add this check, our generic case will also include this part. So here, let me do this, and dp to be 0 times m, right? So how do we interpret this dp? So dpi will be the number of n subarrays ending at index I. So n subarrays, here subarray, of course, we mean arithmetic subarrays. So with that said, what we are going to do is to do the dp update, right? So next, dp update. So for the dp update, that's actually very straightforward. We just need to use the definition. So for I in range, so here I'm going to iterate from 2 up to n-1, right? So what we're going to check, let me change this nums to be a, just for convenience of writing or coding. So here what we are going to do is if ai minus ai minus 1 equals ai minus 1 minus ai minus 2. So in other words, these 3 elements forms a piece of arithmetic subarrays. So basically what we are going to do is to do this dpi equals so dpi minus 1. So this is the number of arithmetic subarrays ending at index I minus 1, right? And each one corresponding to a start for the arithmetic subarray ending at I. And then also we need to consider the longer one ending at I. So we're going to do this. This is going to be this. This will be the number of arithmetic subarrays ending at index I. So if this condition does not hold, then we just set dpi to be 0, because we have already initialized at 0, so we do not need to do anything else. So afterwards, we just need to return. So what we are going to return is actually the sum of this dp table. So notice that, because the first two zeros, if n is less than 3. So here, actually, we didn't enter this for loop. Anyway, let's first do a check. Yeah, it passes the first example. Now let me cook up another example. So let's see. We got 100. Then, so this is the cannot extend this part, right? So we get 200. We get 300. Then we're going to have 4, right? Because this contributes 3, and this 3, 100 to 200 is 300, contribute one more. So now, after we do this, let me copy this part, and we know that, let's call it V1. We know this part we can actually comment out, because of the way we write the code, because we are starting from range 2 up to n minus 1. So if n is less than 3, and then this for loop is not basically plays no role. So we directly sum 2 zeros or 1 zeros. Let's check this one. Yeah, it passes all the cases. Let me call this one V2. This is one solution format. So now I'm going to write another solution format. Let me copy this this part. So I'm going to use 2-pointer sliding windows. This is actually a very common trick. So still, under the hood, I'm still going to want to find for each index. We want to find the number of subarrays. Here, subarrays means arithmetic subarrays, for number ending there, right? So what we're going to do? So we're not going to apply the 2-pointer sliding window to the nums array or capital A as array itself. What I'm going to do? I'm going to apply it to the difference sequence. So here I'm going to do is AI minus 1 for I in range. So we're going to enter it from 1 to up to length A, right? So for convenience, let me copy this part, cut it, and put here n equals length A. So I'm going to have here, right? So with this, I'm going to have a left pointer and a right pointer. So I'm going to start from 0 and 1, right? So if we have two equal elements, it means it corresponding to 3 elements in the original array, right? So this 2 will contribute 1 arithmetic subarray. So that's the marriage. So here I'm going to initialize. Let's see. Maybe we do this at the very beginning. So just for clarity, we're going to initialize a counting variable called result. We're going to return its final state. So this this part we can regard it as step 0, preparation, and then this part is just step 1, 2-pointer sliding window. Here we are setting left and right to be 0 and 1 respectively, and then we are going to iterate. Here I'm going to use a while loop. Well, this is less than n, right? And so here I'm going to check if the difference list, if the left at index left equals this at the right, it means that we find a arithmetic array ending at index right. So what we are going to do is to do this, right minus left, right, and then we are going to move the right to push it one step to the right. This number actually is the increment, or the number of arithmetic subarrays ending at index right. So otherwise, what we're going to do, so because this we need to start over. So like the example 1, 2, 3, 4, 100, 200, 300 previously, right? So what we're going to do is we're going to set left to be right, and the right to be the new left, that is right plus 1 actually. So then we are going to finish this while loop. After we exit this while loop, actually the result is updated. So this is what we want to return. Let's call it step 2. Return the result, the counting, obviously. So that's the return result. This is the second solution format. Actually, if you analyze the code carefully, so there's two. One is based on dynamic programming in the format or representation, and the other based on 2-pointer sliding window. Essentially, they are the same, right? So let's do a check. So here I change this to be V1, V2, and then let's do the check. Here I guess yeah. So it's let's see, it's left and right. Yeah. So length. Oh, right. So here is the left. Let's see. If right is less than this one, we are going to do this check, left and right. So this should be where's the problem? I guess length A. Oh, here. So here I should write a minus 1 because I have done this. So here we should write actually a minus 1 is nothing but a minus 1 is nothing but the length of this one, right? So now let's do the check. Yeah, it passes the example we cooked up, right? And 1, 2, 3, 4 is in this if clause, and 100, 200, 300 in this else. So now let's look at the generic case. Yeah, it passes all the generic cases. So I guess after this version of solution finished, so that's about it for this specific problem. So in this video, we shared two treatments. One is based on DP, and the other is based on 2-pointer sliding window. So in essence, the two representations are different in Outlook, and in the under the hood, they are the same solution, obviously. So with that said, I guess that's it for this video. So if you find this explanation useful or inspired your thoughts, you're welcome to follow up our YouTube channel or distribute and share with your friends. Thank you.